Welcome to Brain Vision.
1 megavolt ampere substation operates at full load at the power factor 0.7. It is desired to improve the power factor to 0.95 by installing the capacitors. Assume that the new substation and distribution facilities cost $120 per kVA installed and the capacitors cost $30 per kVA installed. Then calculate the cost of capacitors needed. B part is find the savings in the substation capacity released, and are capacitors economical for releasing the amount of substation capacity. Cos theta 1 is equals to 0.7. From here the theta 1 value is equals to 45.57 degrees. S1 equals 1 megavolt ampere, that is 1000 kilovolt ampere, and P1 is equals S1 cos theta 1, which is equals to 700 kilowatt, and Q1 value is equals to S1 sin theta 1, which is equals to 714.14 kVAR. Now for the improved power factor, cos theta 2 equals 0.95. From here theta 2 value is equals to 18.19 degrees. From here the improved value for power P2 equals to P1 100 kilowatt. S2 value is equals to P2 by cos theta 2 700 by 0.95 equals 736.84 kilovolt ampere, and value for Q2 is S2 sin theta 2 is equals to 230.08 kVAR. Now for the reactive power across the capacitor, QC equals Q1 minus Q2 is equals 484.06 kVAR, and the cost of installing the capacitors is $30 multiplied by 484.061 is equals to $14,521.80. Now for the substation capacity released, S1 minus S2 equals 1000 minus 736.84 equals 263.16 kVA. Saving in the cost of substation and distribution facilities is $120 into 263.16, that is 31579.20. And the answer for C is yes, because A is greater than the B. The additional system capacity obtained by using the capacitor costs only 46% as much as new substation and the distribution facilities.